All right, here we go. Today it's kind of a review day with one extra kicker of like a really important new thing, but it's mostly review today. And I want to start by just what are things for trig that you have to have memorized. I would say the thing that you've used the most is probably SOHCAHTOA. So I have that, I will have that on here. In fact, I'll do it right now. And I know by now you probably know this, but let's put it on there just to make it clear. If you didn't know it, that would doom you. Like, you got to do sine is opposite over hypotenuse. If you don't know that problem, when you do sine, you can't do it anymore. So SOHCAHTOA is important. I don't think you need to write down its opposite over hypotenuse. I think you have them memorized, but it kind of becomes a pretty impressive list of things you got to know. All right, so if I had to know these two triangles, you should be able to tell them apart. I haven't made you memorize all the triangles that exist, but these two, for sure. So, let's see what you think. Dice of Destiny, who should I call upon? Row 5, person 3, toot toot toot. And that is, dang it, that's where, oh, I switched my hour. You're definitely not George, sorry. There we go. Marit, can you tell me either of the triangles? You pick one. What do you want to do? Excellent. 1 and 1. Now, on the test, though, these were like root 2 and root 2. Is that a thing? Yes, that's a thing. And you should know, ooh, since those are the same and it's a right triangle, that's a 45, 45, 90. You got to be able to recognize it, that if those are the same. But you are right, 1, 1, and root 2 is kind of the classic combo. 1, 1, root 2. And that other one I just mentioned? Well, if you times this by root 2, and you times this by root 2, and you times that by root 2, you will get that triangle, where the sides are the same, but they're different than the classic. All right. Then the other triangle, of course, is the 30, 60, 90. And again, I'm not ripping that most people don't know this. It's just most people have to know this. And it's kind of impressive that you pretty much all do. That's 1, 2. I'm going to move this one up so that it isn't in the way here. 1, 2, and the square root of 3. And I want to take a second to say there's a topic that is like a thing to memorize, and it's how do you find the third side? Like, what if you remembered it was 1 and 2, and you were like, is it the square root of 2 or is it the square root of 3? This is something you should memorize. It's the square root of 2 squared minus 1 squared. You know what I mean? That does come out to square root of 3, but it would remind you that that's how you can find the third side in a right triangle. That's another thing you have to memorize, is how to find the third side in a right triangle. So I'm going to put that on there, but you might want to make a separate triangle for it just to remind yourself that that's a thing to memorize. So like if I give you two sides and it's 5 and 3, you got to know that that third side is square root of 25 plus 9. You know what I'm saying? That's a thing to memorize. Here's another thing to memorize. Sine, cosine, and tangent goes with other things. Like sometimes we just give this to you, but I'm not doing this kind where we say that it's 1 and 2. If I did, wouldn't you be able to know I just gave you two sides of a triangle and you could figure out the third one? See what I mean? But I'm doing the kind where sine is something over something. It's 2 letters, and it's not opposite over hypotenuse. Did you memorize these? If you know it, just be bold. Raise your hand. Tell me what sine is. Yes?
Is it y over r?
It is y over r. Very good. Please complete the rest of this thing. Sine, cosine, tangent, and then what are those other boxes? Those are the sister functions. Again, you have to memorize them. You got to know that sine goes with something. And if you get them confused, boop, another one wrong. So trig has tons of memorize. I tried to show you why all of these things were what they are, so that I don't just say memorize it. But now we're past the point where I already explained why it's y over r, and now you just have to know it. This one, x over r, And the last one, actually, surprisingly, a lot of people get that one confused because they're like, isn't there an r in it? No, it's y over x. All right, now sine goes with a sister function, which will go in this box right here. Row 4, last person, Ashlyn. What do you think sine goes with?
CSC.
CSC is correct. It's cosecant. Thankfully, we don't make people say it, but that's what you would say. Cosecant. Cosine goes with secant. And tangent, row 3, person 1, Sabins.
That's cotangent CO2.
Cotangent, you got it. And then you got to memorize this part. TiVo, how do you get these?
Flip the
Yes.
middle one,
So then what would it be?
R over Y,
R over y. Secant would be,
R over X,
and the last one would be,
X over Y.
you got it. Excellent. Okay. Do you get that this has to be in your head? Like you have to know all of these things. Now, I personally would just memorize this part of the chart. But all of those, all have to be in your head. You can't look them up anywhere. This, you could just remember that they're flips. You know what I mean? I would not try to remember, what is cosecant? Is it r over y? No, I would just try to remember that cosecant is the flip of sine. All right, here's that same list again, so we're not going to bother doing it again. And we will come back as we need things to add more to the memorize sheet. But wait, there's one more I want to add right now. I just taught you this yesterday. A, S, T, C. And yes, it's all students take calc, but there's no reason to write that down. What it means, though, is all are positive here. Like all of the trig functions are positive in that quadrant. Next thing that you have to memorize is if I say it's in quadrant 2, you got to know where that is. That's another memorized thing. Do you know which quadrant 2 is? You probably do. But I bet there's one kid in the room who'd confuse it, and then they're going to get that one wrong. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. We usually use Roman numerals, but I'm fine with you putting like Q3 for quadrant 3. Okay. All of them are positive there, and I think you're smart enough to know this is sine, but what is it about sine? What's the point? Sine what? Sine is, it's the only one that's positive. Good. And tangent's positive here, and cosine is positive here. We're doing 2 more chapter tests on trig. You're going to use this on both of those tests. Got to know these. So, for example, I could say, in which 2 quadrants is tangent less than 0? Don't say it. I want you to answer it. And put this right next to this memorized thing. That's why we need it. Because you'll have to find the 2 places where tangent could be negative. That's the kind of question this helps us answer. Well, tangent's positive here and here, so then tangent must be negative in quadrants 2 and 4. Does that make sense to you? All right. Okay. Do you get that was a ton of stuff you have to memorize? And if on the next test any of those are missing, you're probably just missing a point. And you can only get 2 wrong and keep your A. And I know most of you are going for the A. All right. Okay. So now let's go down to this problem. It will use some of that stuff we just memorized, and it's about radians. Ooh, and that brings up another memorized thing. I'm going to go back to my memorized sheet and say, do you know what pi over 2 is? Do you know what pi over 3 is? Do you know what pi over 4 is? And we skip over pi over 5, but how about pi over 6? Those you have to memorize. Do you know how many degrees they are? I think most of you got them, but again, there's 2 kids. But this helps to remember it. It's worth it. In a moment, I'm going to have you compare your angles with the kid next to you. By the way, hint, pi is like 180. So if you want to figure out the degrees, it goes really quick if you just can divide. All right. Check with the kid next to you. See if you have those four right. Okay, so pi over 2 is 90. Pi over 3 is like 180 divided by 3, so it's 60. Pi over 4 is 45. And pi over 6 is 30. You really got to know those. And I'm kind of assuming you know the big daddy of them all, which is what pi is. Let's just put it on there, because you really have to know it. What is pi? 180. Look at all this stuff you have to memorize. That's why trig is harder than last semester. Do you get that in last semester? We pretty much didn't have to memorize anything. And all of a sudden in this semester, you have to memorize a ton of things. Now, some people, it plays to their strength, because you tell them something once and they just remember it automatically. Like, they're good, they'll know it for the next 6 months. Or for some of you, this is like not your strength. So some people do worse on trig just because they aren't good at memorizing. You know yourself. I bet you if I made you raise your hands and be honest, a couple of you would be like, yeah, I suck at memorizing things. Well, then at least you should make flashcards out of this, because you know yourself and you should drill on them. And if you do, you'll get them. Okay, so back to this sine of 2 pi over 3. If you know where 1 pi over 3 is, that's what I'd start with. Here's where pi is. 1/3 of the way to pi. It's like you start here and you keep going until you're 1/3 of the way there. You don't want to go to half. That doesn't make sense. That's where 1/3 of the way is. So then you go like twice that far and you're about there. I hope that was natural and easy. And now make the triangle around it and now answer the question, what is sine of 2 pi over 3? Once you got the triangle drawn and you got all the sides and all the angles, trig is not that hard. But you got to draw that triangle. And there is a certain kind of problem where you can't make a triangle. And then you got to use the y over r thing, or x over r. All right. So I think I'm holding you up here, so I'm going to get this going. This is 60, this is 30, this is 90, 1, 2, square root of 3. What's the most common mistake? Negative. That's a -1 because it went from the origin, it goes left, so that's a -1. And now sine of this is opposite over hypotenuse. And what if a kid did opposite over hypotenuse and another kid did y over r? You'd get the exact same thing? Y value is this, the radius is that. Look at that, y over r, or opposite over hypotenuse, same thing. Okay, so next kind of question we need to be able to do is, I just give you a point, and you're supposed to find cosine of this huge angle. Hint, you'll use the reference angle. So maybe you should draw a reference triangle. Pausing while you try this. All right, so did you draw this triangle around this and then go side -3, side 2? That was really important. If you knew that, then you probably knew you make square root of 3 squared is 9, 2 squared is 4, add them together. Who had square root of 13? Raise your hand if you did. Cool. Then cosine is adjacent over hypotenuse, or x over r. I'm going to do it that way just to show you I can. The x value is -3, and the radius value is the square root of 13. And you could have got that same thing from ka, adjacent over hypotenuse. All right. And that does bring up, then why do we even do, like, when do we do the kind where you do x over r, and when do you do the kind anytime you want? You can switch between adjacent over hypotenuse or x over r. It doesn't matter to me. Okay, now this is important. This is the big new thing for today. Would you please draw this situation? ASTC with the circle and the lines, that's like your standard circle now. and sine is negative, and now you should be zooming in on, okay, well then if sine is negative, because see, it says negative a half, then it can't be here, because all of them are positive here. Do you get, I can't make sine be negative there. So that's out. Sine is also positive in that quadrant, so that's out. Because it says sine is negative a half. That means, now this is a part that I didn't stress enough in my first hour. That means there could be two triangles for this. That sine is negative there, and sine is, oh wait, I should draw short fat triangles, not long skinny ones, sorry. Because it can really make a big deal sometimes. Sometimes it doesn't matter, but. Okay, now it also could be here, and I want you to process that there are two possible triangles when sine is negative. Do you get in both of those quadrants sine is negative? Let's draw both triangles all the way out. I know that this part is going to cancel one of them, but still, some of your problems for today make you give two answers. So let's draw these triangles. Sine, here's the key angles. Now label all sides. I know you've been paying attention a long time, but we're almost done. Stay with me if you do this. Label all the sides of both of those triangles. Hint, they told me opposite and hypotenuse. Opposite was -1. Opposite from this angle is over here. Hypotenuse, 2. Oh, I remember this one. 1, 2 square root of 3. What's the most common mistake in circle trig? Negatives. That should be negative. Process that. Sine is opposite over hypotenuse. That's why I knew where to put the 1 and the 2. And then I remembered to put on my negatives. For this other triangle, opposite, -1, hypotenuse, 2, square root of 3. Where is the negatives? I guess there's only one here. It's that one. Okay. Now, do you get there are two angles that are kind of the same and kind of different? This one's 30, and this one's 30, but neither one of them is actually 30 because of where they are. The answer to this question is not 30. We do want to know the angle, but we want to know this answer. It's not 30, it's a whole bunch of 30s. It's 180 plus 30. This spot here is not 30. This is 180 plus 30 is 210. Process that for a second. The answer isn't 30, it's 210. And the other answer is going to get thrown out. It would have been 360 minus 30 is 330. And I know some of you are like, why isn't it 30? Because that's the reference angle. 330 is where you are in the circle. So 330 was a right answer, but why does it get canceled? Because it says cosine is also negative. Is cosine negative in this quadrant? So that gets thrown out. You could have read the whole problem and thrown it out from the beginning, and you would only had one answer. But I just wanted to show you why a lot of times today you get two answers for things. And I know some of you are still stuck on this, like, I get it was 30, but why is it 210? Because 30, actual 30, is only right there. When you're over here, you're not really at 30, you're at 180 plus 30. Yes?
Why did we cross out the
Why does this one get thrown out? Because the problem said cosine is also negative. And that can't happen in this quadrant. I know, super hard problem. That's an R3. Probably the hardest question on the test. Just like that. So we'll practice it. And you'll get good at it before we take the test. All right, so let's make, there's one more type of question I want to do, and then I'll come back to another one like that. This one, if you try to use opposite and hypotenuse, it's not going to work. Because why? Because there's no triangle. So do it the other way you can do sine. And some people get confused on what the radius is. Just imagine drawing a circle around this thing. If you were going to draw a circle around it, it'd be like that. So then think of it that way. That'll tell you what the radius is. Because sine is y over r, and the y value is 0, over the radius is 2. Why not negative 2? Because radiuses are never negative. Ooh, I'm going to put that on my memorize sheet. It's a fact you got to know, right? Radius are positive. They're never negative. Just a fact you have to know. The radius will always be positive. So back to this problem, my radius, I could argue that this distance is negative 2, but no, that's a direction. The radius is 2, because you can't have negatives to the radius. So either way, do you know that 0 divided by 2 is 0? So the answer is 0. Cool. Now, just a second ago, we were doing angles, but this isn't an angle. What is the angle? If you don't know that that's 180, I understand. But now that I say it, does it make sense to you that that's 180? That's the angle. I thought you called it pi. Well, sure. If you want to do radians, it'd be called pi. All right. I know this is intense. Especially if you've been gone for a day or two, you'd be like, holy cow, my brain's going to explode. All right, let's do one more of those problems where I say cosine of the angle is negative root 3 over 2. Now, I told you cosine was negative. You're supposed to be able to deduce which two quadrants you can draw triangles in. This one I'm going to keep simpler. I'm not going to tell you another function like, oh, by the way, tangent's negative. I'm just going to do one. And that means you're going to have two answers. There's two answers for this. And what are the answers? Well, it's not the triangle, it's the angle. You were looking for the angle. So first you better draw a triangle and then figure out what is the key angle. So many little things to memorize. Cosine's negative, only in 2 of the quadrants. Narrow it down to those 2. Then draw the triangle. Then you have 2 of the sides. Then figure out the third side. All right, I'm going to pause while you try this one. Okay. ASTC. I would also put a circle in. I told you we were going to do about 100 of those. I suppose we've already done like 12, 13, maybe even like 20 by now. I don't know. I'm ruling this one out because all of them are positive there. And cosine's negative, it says right there. And then if cosine's negative, it can't be here because cosine's positive there. How many of you knew to draw a triangle here and there? You got that? Now you got to figure out what sides and angles are in there. Get that all done. And then remember that if you're like, oh, it's 60 degrees, I guarantee you the answer is not, the final answer is not 60 and it's not 30 and it's not 45. Because you got to go all the way to here. And you got to go all the way to here. Because 30 and 60 live in quadrant 1. It can't be that. Sure, the reference angle can be 30 or 60, but the actual final answer can't be 30 or 60 because you're not in quadrant 1. All right, so I'm going to put in my little theta there. Why? Because it's called the central angle, the reference angle, and those are important. These are right triangles, so I'm going to do that. Then I'm going to go cosine is adjacent over hypotenuse. Well, the adjacent side appears to be negative root 3. And that's the same on both triangles. And then the hypotenuse is 2. I'm going to put that here and here. And that must mean the last side is here, and it must be a 1 because it's the 1, 2, root 3 triangle. And then what's across from the 1? That's a 30. So then I know these are 30. So why isn't the answer 30? Because 30 lives over here. It's not 30. It's a whole bunch of 30s. I could say it's 150. Raise your hand if you had 150. Sweet. Or I could say a bunch of pi over 6s and say 5 pi over 6. If they needed radians, 5 pi over 6 is even better than 150. But those are the two right answers. And the other one, for way around to here, you have to go past 180. So it's 180 plus 30, 210. And if you wanted to do radians, you'd do it in pi over 6s. It'd be 7 pi over 6. That is intense. And that's the one thing that wasn't reviewed. Okay. Now, to make you feel a little bit better about it, if you did get this problem wrong, you could still get a straight A on the test. You just have to get everything else right. And that's kind of hard. So I wouldn't write these off. You can still do this. You might need a few to practice it before you start getting the hang of it, because this is tough. And on that note, it's time to go do your homework. So everybody find the worksheet that is posted for today. Pull it up right now. We'll start it together. I will have you skip several because it's a little too long. For this first problem, you definitely should do it. It's like the only one of its kind. And this kind's on the test for sure. I mean, I would think it would be. Honestly, I haven't even looked at the test yet, but I'd be shocked if they don't have one like this where they give you a point. So let's try it. 5 comma negative 12, would you agree that's down there somewhere? And then you go, shoop. And then you can draw a triangle around that. And you know 2 of the sides. And you're off and running. They want you to do sine, cosine, tangent, all of those. And you might be like, can I use opposite over adjacent? Yeah, you can do it that way. Or you can do sine is opposite over hypotenuse, or sine is y over r. And it'll answer this kind of question. And this must be 5, and this must be negative 12. And then I'll save you some time. It comes out to 169, and then you got to do the square root, so what's that? Say it if you know it. Square root of 169. 13, correct. And since it's a radius, it's always positive, so... And then... sine for this angle. Don't overthink this. Here's the key angle. Sine is opposite over hypotenuse. Would you rather do y over r? Then do it. It'll work. It's the same thing as opposite over hypotenuse. And do it for all 6 trig functions. But I don't get one that's this kind, Mr. Server. Well, then draw the picture. They said tangent's negative. There's 2 quadrants where tangent's negative. But wait, sine is positive. Then there's only going to be 1 quadrant where it works. If tangent's negative right off the bat, it can't be here, because they're all positive there. A, S, T, C. And if tangent's negative, it can't be here. Then you got to be smart enough to know if sine is positive, there's only one of the 2 quadrants left that could work. Draw the triangle there, label all the sides, figure out the answers for all of them. I usually set them up like this. Sine is this, cosine's this, tangent's that. We already know tangent, they gave it to us. And then the 6 trig functions, cosecant, again, I'm going from my memory banks, secant and cotangent. 6 answers, except they gave you one of them, so 5 answers. All right, you should definitely do number 3 also. These are the hardest ones. I know they're not fun, but that's what you got to learn, really. Then in here, we have a little too much practice, so we are going to skip 7, 8, and 9. So everybody cross those off. I think that's overkill. So on the first page, just do 1 through 6. On the second page here, it's actually 4 problems tall. We're going to skip the last one on all of these. You know, if you want extra practice, do them. Like if you go through this and you get them all wrong, you probably should go try those. But I think this would be cutting it down so you're not doing busy work. And you do have some time in class here to complete this. And I want to do number 10 with you because tons of people got stuck on number 10 because they forgot there's 2 places where the answers are. So everybody on number 10, make me a circle with the whole ASTC thing in it. All right, I got that done in 10 seconds. Copy that for number 10. And everybody's like, well, where do I draw the triangle? Can I just draw it here? No, you can't. You can draw it there because cosine is positive, but you have to also draw it here. But cosine isn't negative, it's positive. So these are out. Don't forget to draw the 2 triangles for us. And they've given you 2 sides. You're supposed to know how to figure out the 3rd side. Label them, and then when you get your answers, if this looks like it's 30, maybe it is 30 because it's in this first quadrant. But this other one, there's no way it could be 30. It's all the way around to there. It's a huge number. It's like 300 and something. Okay. Let's practice those. Remember that they only give you 1 side. They gave you 2. Let's put it over 1. That'll happen in other spots too, like -1 over 1. They gave you 2 sides. And don't forget that if you're having trouble, like, where the heck is this triangle? Maybe it's a quadrantal. On this one, the answer is going to end up as one of these spots. All right, that's enough hints for you. That should help. If you need help on one-on-one, please walk on up and help me. Otherwise, next week, the next chance for individual help is Thursday. So if you want one-on-one help, use this prime time. It'd be a great time to do it. Or anchor time, don't forget that. Anchor time's on Tuesdays and Wednesdays. Thursday anchor time, I am part-time, so my anchor time is outside when I work. So Thursday anchor time will never work, but I'll let anybody come to any of my anchor times. You don't have to ask permission. You can just show up on Tuesdays or Wednesdays. All right, that's all I got for you for today.